When graphing a rational function, it's important to make sure you can identify what the vertical asymptotes are. The vertical asymptotes are going to be the values that make your denominator equal to 0 that simply cannot be divided out. So what you simply want to do first is always look to simplify your denominator first. Notice that I have a quadratic, which hopefully I can be able to factor. Okay. So now I've simplified this, I've put it in factored form, and what we always want to look for is those holes. Is there these expressions that's in the denominator up there in the numerator? And no, so therefore I know these are what we call non-removable discontinuities. These are our vertical asymptotes. Now, to actually identify the vertical asymptotes though, we want to know what are the values that are going to make this denominator equal to 0. You could set it equal to 0, apply the zero product property and solve, or you can actually just visually see when x is equal to 4, this is equal to 0. That means my whole denominator is equal to 0. So therefore, that is a vertical asymptote. Don't say -4 because you see it right there. -4 does not make any of these expressions equal to 0. So -4 is not a vertical asymptote. Over here, you can see that x equals a -1, not 1. But when -1 is plugged into there, that makes that 0, which makes that 0, or that's 0. So when you multiply by that, it's going to be 0. So that is also going to be your vertical asymptote.